Hi Pre-Calc, let's look at section 9.4 sequences. So a sequence is a pattern of numbers. And there are lots of different types of sequences. We're going to be kind of unpacking some of those. There are finite sequences and infinite. I imagine you could guess what the difference is. A finite sequence has a set number of terms, while an infinite sequence would be never ending. Often we use the letter A, to denote different terms in a sequence. So a sequence would look like this: A1, A2, A3, all the way to A sub n, where each of these is a term. For example, this is term number 1, the first term. This would be the nth term. N as in to say we don't necessarily know where it ends, and of course, like this is term number 2, the second term. So what else do we need to know? How a sequence can be defined. How a sequence is defined. There are two different ways that we can define a sequence. We've got a recursive definition, and we've got an explicit. If you think about what those words mean in your everyday language, to be recursive means kind of happening again, recurring. And to be explicit, obviously, if we were talking about language, it would be like inappropriate language, but to be explicit means to be extremely clear. So we can kind of use those to help us with our definition. A recursive sequence defines a sequence. Oh my goodness, I'm so sorry. Defines a sequence by using the previous term. So one example of a recursive sequence could be if we consider the even numbers, where let's say the k plus 1 term is equal to 2 times the k term, where a sub 1 is equal to, we'll go with 1. So that would mean our second term, which is a 1 plus 1 is 2 times our first term. So the second term would be 2. And then we would keep going. So this is 1, 2, 4, etc. Or our third term, which is 2 plus 1. So that's the k plus 1 is equal to, oops, kind of messed up there, is equal to 2 times a sub 2. Or the third term is 2 times the second term. 2 times 2, which would be 4. An explicit definition of a sequence is a way to define a sequence that uses the first term. Way to define a sequence that uses the first term. So that would be a sub 1 and the term number of interest. Term number of interest, which would be n. So we would say like a sub n is equal to a1 plus 3 times n. So if I wanted to find the second term in the sequence, I would take the first term and add to it 3 times 2. Now I didn't give you what the first term was in the sequence, so it doesn't necessarily really help you, but we will be doing a bunch of examples in class to look at this. If you would like, you can pause the video right now and write these in your notebook. These will be the first 2 problems we look at in class together, and they would be really good for you to have written down. The other thing that I want to talk to you guys about today is the difference between arithmetic and geometric. So if we have an arithmetic sequence, that means we are adding or subtracting as we go along the sequence. So we've got term number 1, and then we've got term number 1 plus some common difference, and then we would add another, so it would be A1 plus D, but of course we wouldn't necessarily write it like that, so I'm actually going to shorten it to plus 2 times D, and then we would add a third, right? A1 plus another one, 3D, and this continues on and on until we would be ended, where D is known as our common difference. And we write it as plus D, but D could be a negative thing, which would mean that we would be subtracting. We could write this, as explicit or recursive. And I think I'm going to start with recursive because this one makes the most sense to me. If I want to find the nth term, I want to take the previous term, a n minus 1, and add to it the common difference. It's as simple as that. In an arithmetic sequence, we take the previous term and add to it that common difference. What about an explicit definition? Well, to find our explicit definition, we could kind of consider what we've got up here. So this is A1, this is A2, this is A3, A4. So how could I write this to generalize it? Well, any term is equal to, notice that each of these terms has an A1 at the beginning. So is equal to the first term plus how many copies of that common difference? Well, notice this fourth term has 3 copies, this third term has 2 copies, the second term has 1, so plus n minus 1 times the common difference. That would be an explicit way to write our arithmetic sequence. What about a geometric sequence? Geometric sequences are sequences where we are multiplying or dividing every term by the same thing. So if we were to write them out, it would be A1 and then A1 times R. So we're multiplying it by R. And then if we had the next one, we take the previous term, A1 times R, and multiply it by another copy of R. But of course, I wouldn't write it like that because we're smarter than that. R times R is really R squared. So it would be A1 times R squared, A1 times R cubed, etc. And again, let's consider these. This is our first term. This is our second term. This is our third term and our fourth. Where, of course, R is the thing that we are multiplying by everything, we write that as a common ratio. And just like with our arithmetic, I can write an explicit definition and a recursive definition. Again, I think the recursive is maybe a little bit easier. So if I want to find any term, we'll say a sub n. I'm going to take the previous term, a sub n minus 1, and I'm going to multiply it by that common difference r. For an explicit, let's consider what we've got up here. Notice if I'm looking at my third term, I take the first term and I multiply it by 2 copies of that common ratio. Did I say common difference? I apologize if I did. So that means any term here is equal to A1 times R to the n minus 1. One less term than what we are looking for. We will look at a bunch of examples together. I'm going to put this on the screen for a moment if you want to pause the video to write it down. Otherwise, there are blank copies of these notes on my DSHA. So this will be example 2. Here would be example 3. And then we'll talk about example 4 together as well. Again, you can pause the video if you would like. The limit of a sequence is something we're going to talk about, but I think we're going to hold off on this until class. So if you want, this would be the example we would do for the limit of a sequence. Otherwise, I hope you have a beautiful rest of your day.